Welcome to The Explainer. Today, we're setting the stage for a truly fascinating look at how a massive architectural marvel, a literal giant of engineering, didn't just break records, but actually revolutionized modern economics. We're looking at the Millau Viaduct in France, and we're going to explore how shifting our economic perspective from simply building things to, well, actually guaranteeing their performance changes absolutely everything.
Okay, let's dive into this, and I want to hook your attention right away by emphasizing this absolutely staggering number: 120. When the Millau Viaduct was constructed, it wasn't just built to standard specs. No, it came with a 120-year durability guarantee. Think about that for a second. An infrastructure project guaranteed by its builders to last well into the next century. How on earth did a government manage to secure a deal like that?
That brings us to part one, the funding problem, tracing back to 1998 in a massive 2 billion franc roadblock.
So, back in 1998, the French state desperately needed a new piece of major infrastructure to relieve some really severe traffic congestion. But, they hit a wall. The estimated construction cost was 2 billion French francs, which is roughly 400 million euros. And because the public coffers were, well, pretty much empty, the government was essentially forced to toss out their traditional civil engineering playbook. They literally just could not afford to procure this bridge the way they normally would.
Now, before we look at their solution, let's look at that old playbook they had to abandon. In the standard linear industrial economy, public markets usually dictate the entire delivery process. The focus is really just on the use of objects, moving in a straight line, from exploiting natural resources to producing materials, manufacturing the objects, and then distributing them. When a state builds a bridge this way, they pay for the construction process piece by piece. But, as you can probably guess, this often leads to inefficiencies, budget overruns, and crucially, fractured liability, meaning the builder just kind of walks away once the concrete is poured.
Which leads us directly into part two, the BFOT concession, and a total paradigm shift in procurement.
Because that linear model was just way too expensive, the French state went with a radical solution to solve the funding crisis. They utilized a BFOT concession. That stands for Build, Finance, Operate, Transfer. By using this model, the French state cleverly positioned itself not as a traditional client, but as a public performance procurement manager. Basically, they said to the private sector, look, we aren't going to tell you exactly how to build this or pay you for the materials. Instead, we are demanding a final performance. You finance it, you build it, and you operate it entirely at your own risk. Let's move to and see how this builds across a massive timeline. The procurement decision was made in 1998. Construction began in October 2001, and because the builders were bearing literally all the financial risk, they were highly motivated. The bridge was commissioned in December 2004, right on budget and actually 3 whole months ahead of schedule. The concession period for them to operate the bridge and collect tolls lasts 78 years, ending in 2082. And that incredible durability guarantee we talked about? That stretches all the way out to 2124. Absolutely wild.
Moving into part 3, the system's performance design team, or the actors behind the guarantee. So who actually pulls something like this off? Let's look at the personas who had to execute this monumental task, turning this brilliant economic theory into, well, actually, into a physical giant of concrete, steel, and suspension cables. Back in 2000, Compagnie Eiffage won the public tender by creating a brilliant organizational structure that mirrored the French administrative structure itself. Eiffage SA stepped up as the producer and financier. The French state acted as the policymaker and procurement manager. Eiffage then set up subsidiary companies creating CEVM to take on the role of the client and future fleet manager operating the infrastructure, while Settec took on the contractor role.
I really want to point out this specific contractual clause right here, because it's the linchpin of the whole project. By committing to finance, conceive, operate, and maintain the infrastructure at its own costs and risks, the Eiffage-led team was forced to take sole responsibility for the bridge's entire lifespan. They relied exclusively on private equity, loans from the European Investment Bank, and, of course, future toll income. So if the bridge failed, or if it required excessive maintenance, the financial loss would fall entirely on them, not the taxpayers.
This brings us to part 4, the performance economy, where you're selling results, not just steel. And by the way, this project was so groundbreaking it even attracted renowned British architect Norman Foster to its systems performance design team.
Actively contrasting these two regimes makes the genius of this so apparent. Over on the left, the traditional regime dictates the delivery process, which leaves you with that fractured liability.
The builder gets paid to build, and their liability usually ends shortly after completion. But on the right, in the performance economy, the authority demands a final performance and shifts the sole liability directly to the builder. I mean, think about it. When the builder knows they are financially on the hook for the next 78 to 120 years, they are incredibly incentivized to design for flawless, timeless quality right from day one.
Now, what's really interesting about this slide is how the very definition of quality changes here. In a normal linear economy, quality just means the absence of manufacturing defects at the point of sale, right? But in the performance economy, quality is actually a vector. It sits right between technology management, risk management, and time management. Quality is redefined as system optimization and functioning over long periods of time. You literally have to balance technical efficiency with loss prevention over decades.
And this brilliantly illustrates the core business models at play. You basically have three pillars working together: retained ownership and liability, OEM skills, which is original equipment manufacturer knowledge, and O&M skills, meaning operation and maintenance experience. When you combine the retained liability of owning the asset with the skills to build it and the experience to maintain it, you create maximum sustainability and maximum profit. Eiffage didn't just build a bridge, they built a completely self-sustaining long-term performance machine.
So, the crucial point is that this masterclass provides universal lessons that apply far beyond megastructures and bridges. First, public authorities must define the expected final performance they want. Second, they absolutely must renounce control of the delivery process to let innovation thrive. Third, the economic actors providing the solution must accept sole responsibility for the delivery. And finally, those actors must hold liability over the full service life of the product. That is exactly how you guarantee excellence.
I want to end this explainer by throwing this back to you. It's a pretty provocative thought. If you had to accept sole financial responsibility for your product's performance for the next 120 years, how would you build it differently today? What materials would you use? How much more attention would you pay to maintenance and resilience? Applying the mindset of the Millau Viaduct to your own industry just might be the key to unlocking true sustainability and long-term profit. Thanks for exploring this with me, and I hope this leaves you eager to uncover more about the incredible potential of the performance economy.